Okay, let's run to the next session. We're going to have Nathan Shama with us. He's going to talk about a very exciting project that he has been leading. He's a theoretical physicist and CTO at Unitary Fund, which is a non-profit organization that supports quantum ecosystem, which is exactly the topic of this session that we are going to talk about. Development of easy-to-use quantum error mitigation of noisy quantum computer and contributing to the MITIC and open source Python toolkit. So without further ado, I want to give the screen to you, Nathan, to tell us more about this project that you have been leading with others. Please, go ahead.
Thank you, Elam and Olivier, and to all the organizers of this amazing conference. It's been really a pleasure to attend, even if virtually. So yes, I'm gonna speak about the work we're doing at Unitary Fund. And this is a nonprofit, as you rightly mentioned, Ella, that aims at creating a quantum ecosystem that really benefits the most people. And I'm really happy to echo the same sentiment that was expressed by the Minister for Digital Transition, Cedrico, at the kickoff of this conference. And hopefully this is what we're doing, and I will show you a bit of what we're doing at Unitary Fund. So open source projects. I mean, I hope everyone is familiar with Wikipedia, and hopefully not only with reading entries, but also editing them. That's the core concept of open source. Anyone can contribute to such large projects. And the researchers in the audience certainly know the archive, which is this open access database where researchers, especially physicists, submit their papers. And then there are, plentiful examples, but let's mention Linux. And all these projects, for example, the Linux operating system, have some backers. And let me just mention that while these are usually non-profits or consortia and so on, the value also for the businesses, it's incredible. So there is a recent report, fairly recent report by the Linux Foundation, in which they estimated that if someone were to create from scratch Linux and its ecosystem, it would be something worth around $5 billion. So the benefit for science, knowledge, and research, it's clear, but there is also a shift occurring more recently in the way businesses use open source. So here is just some headlines and it's just a gist of what's been happening. Microsoft recently acquired what is the tool that is mainly used to collaborate on open source projects, GitHub. IBM acquired the software company Red Hat that mainly worked with open source for like a huge amount of money. And then even if you look at cutting edge applications such as machine learning and with the prospect of AI, Google and Facebook, they do back their sort flagship projects in open source. So where does come the quantum ecosystem? This is just a graphic that is missing many of the players and many of the amazing projects, but it's just a depiction to show that starting from really grassroots and now robust projects in academia that started fairly recently if we compare it to other open source projects beyond quantum. When we've had like an intentional openness in the early quantum industry, so to say, thanks to the commitment of several industry players. And now we have what we like to refer to at Unitary Fund as a quantum jungle, like a really open environment where there is really an ecosystem of company-backed, academia-embedded, or startup-based open source software projects. What do we do at Unitary Fund practically? So there's really two main things we're doing. One is we run a very simple microgrant program. These are $4,000, no strings attached grants that can be given to anyone applying. It really takes like a couple of minutes to apply. And I will mention some of these projects. And we're thankful to the corporate sponsors that are allowing this program to run. It's in second year. We're fundraising for the next year. And anyone interested in the audience, please do reach out, because I'm really excited by the impact that this grassroots and really bottom-up approach is having. And it's something to consider also in relation to top-down and coordinated efforts, such as the future and upcoming French quantum program, or the ongoing National Quantum Initiative in the US. There is another side that actually it's also inserted in this National Quantum Initiative program, that is the in-house research we're doing at Unitary Fund. So you can see it a bit like an inspiration of OpenAI for quantum. We're developing open source programs and projects for research, and we're focusing right now on what we think it's something really relevant, which is error mitigation for current noisy quantum computers. And the program, the library that we're developing in Python, it's called Mythic. And then I will also mention the support we aim to give to more established projects, such as Quantum Toolbox in Python, that is used by many physicists in the audience, I'm sure. And we're doing it thanks to collaborators across academia, such as Johns Hopkins Applied Physics Labs and other partners. So some details, because really, how do you evaluate the impact of the work of a nonprofit? Is not on the value of the equity you have invested into, but there is a social impact, but also very practical metrics, thanks also to the fact that we do help folks develop their own open source projects mainly. So this is our metrics from the microgrant program. We say small microgrants and a big impact. So far, in a little bit less than 2 years, 30 projects have been given out from folks to 14 countries, 4 continents. Publications are in top-tier journals, but it's not only that. It's also the fact that what could be a part-time hobby from an IT specialist, not part of a quantum academic ecosystem, then translated into venture-funded startup by Finnish, that is EU-based investors. 12 open source libraries, and a metric that I particularly like to highlight is that 7 folks now work full-time in this field. And all of this has been possible with only $90,000 of investment. I know that some of the speakers in this roster have been successful in raising much higher orders of money for their startups and companies. But this, I think, it's really a metric highlighting the efficiency of this project, because even if you compare it to a very academic-based figure of merit, which is how much a PhD student costs, for example, in the US to a university, it's roughly in this range. So now, just some examples of the projects. These are 3 projects, but there are many more. You can go to unitary.fund to find out more. One of them is QREC, which it's a quantum simulator. So it's a simulator that runs on real computers, classical computers, not quantum prototypes. And it does emulate what happens in a quantum computer. And this is very important because quantum computers are prone to error, their uptime is sometimes expensive, or there are queues. And so the interesting part is that this project, as you see in the graphic on the bottom left, was able to outperform flagship emulators, for example, developed by IBM or Google. QNetSim, this is something that popped up earlier in the conference, and I also know that Elan Keshafi has an academic interest and a vested interest in it. It's when we speak about quantum technologies, there are not only quantum computing startups or endeavors, but there's also, like, under this umbrella name, many more things. And so If we think about quantum networks, QNetSim is a project that aims at simulating what will happen in the quantum internet of tomorrow. There is protocols that need to be simulated, how do we share entangled information, and so on, in different nodes, and so on. And then another example I'm bringing, it's a quantum compiler that performed very well, or for many benchmarks that are summarized in this table, but are not so easy to grasp right now, against state-of-the-art compilers such as those developed by Cambridge Quantum Computing Tickets compiler. And then we're starting to see some network effects. And this is amazing because, for example, Yao.jl, which is a library developed in Julia, which is this very modern, scientific-oriented, and transparent language. It's a library that allows users to design software and algorithms for quantum circuits, has now been inspired by PyZX, which is a ZX-based calculus library, to develop their own ZX calculus library based on a domain-specific language called YAO-Lang. So I'm also happy that earlier in the conference, the power of ZX calculus was highlighted. PyZX has also been a successful project in terms of research scientific output, with 2 papers already on the archive and published. And here on the right, you can see an example of how a quantum circuit can then be described in terms of these diagrams that are typical of ZX calculus. And then through the synthesis of these diagrams, one is able to distill a more efficient quantum circuit. And let me mention how we're doing the work we're doing. So first of all, it's thanks to the technical team at Unitary Fund. We call it Unitary Labs. And we're really leaders in quantum open source software creation. We've developed the first instructional languages for quantum computers, put on the cloud the first startup-based quantum computers, leading large communities that revolve around quantum projects, or we benchmark quantum computers also with high-performance computing. But then it's also thanks to a wider network. So speaking about an ecosystem, we really rely on the really important work volunteered by advisory board members that help us review and collegially decide which microgrant should be awarded to the many applications we are receiving. And then there is this community of grant winners that is really valuable, through which we can see interaction, and we're really excited about new announcements that will come on the Unitary Fund website in the following weeks. Now, briefly mentioning what we're doing on the research side.
Nathan, you have 2 minutes.
Yes?
Sorry, just to keep in the time, you have 2 minutes to wrap up if you can, please.
Yes, it's there. So we are working on error mitigation, and error mitigation is approximate error correction working today. So we think that we need a tool that will allow standard benchmarks and a reduced time to reach the state of the art for all of these projects that I've shown are there in the ecosystem. So anyone is welcome to contribute, and we hope there will be a snowball effect to the development of this Python library, which is called Mythic. You always need a Q in quantum programs, and it works with major platform and standards. For example, here I'm showing Qiskit and CERT. We've already been testing on real hardware, and we've seen like a 22-fold improvement on the errors that affect these noisy intermediate scale quantum computers. So please do check out this project. And on the last minute I'm given, I just want to mention 2 things in which we're helping also companies in France leverage open source. With a technical advisory at Unitary Fund, we're helping Pascal put their quantum devices on the cloud and leverage on QTIP, this quantum toolbox in Python I mentioned earlier. And then we're also helping these large established grassroots projects really have a governance that help them work better. And this is very important in open source. And I'm happy that Bruno Sportis, the CEO of INRIA was earlier in the conference, because we're also doing work similarly, as they mentioned, with scikit-learn, which is an open source project, to some extent very similar to Qtip, but working in machine learning. So we hope to help more and more projects like Qtip. So how do we set up our program? We think that one thing that is really great, and this is like basically this last slide, it's really to set up a fellowship program that will help folks to work remotely on open source beyond the publish and perish or perish. It's also like publish and perish sometimes, but publish or perish paradigm of research in academia right now. So please, if you're a corporate sponsor or institutional sponsor, consider joining and supporting Unitary Fund activities. Please do get in touch at nathan@unitary.fund. And then if you're more involved and want to have a hands-on involvement on code or mentorship, or please helping spread the word, please do so and check out unitary.fund online.
Great. Thank you so much for this very interesting talk. I'm sorry that we needed to cut it short. I'm sure there is plenty of questions. I'll ask one quickly and then trying to move. You know, it just happened, as you already mentioned, it's getting really busy in this domain of quantum software. We heard about Amazon, who's trying to bring a uniform platform. We heard about, you know, other activity like Atos, who's trying to be a middleware, is doing it. We are hearing about lots of hardware companies that they have their whole full stack for software, and we're hearing about you. So what is the view that you have these things are connected? You know, if you're from outside, which language you go, how do you contribute? So how do you see the benefit of this ecosystem by its own contributing to the each other effect?
Yes, and I think that this is a great question that comes to mind, especially to folks that are newcomers and they don't have unlimited time to learn what is going on in this ecosystem. So they really want to prioritize what they decide to work on or to look more into. So we have resources on Unitary Fund website that help with that. And we're actually funding projects such as full stack quantum computing.tech that is helping, let's say, organize all this knowledge and all these possible venues so that each one can find the best solution for themselves. And then in general, I would just say that this is an ecosystem, it's a dynamical system. It's a driven dissipative system. Many things will not work. And I think the best way to test them is to put an open source early on, because you really need, in general, if you're producing such solutions, the feedback of a research community.
Okay, thank you, Nathan. We have to close. Just remind me, in which time zone are you exactly right now?
No, right now I am in your time zone, so I'm based in Italy, so
okay.
that was not a problem.
Thank you very much. See you next time.
Thank you all.